Welcome back. In this video, we're going to implement spring joints, and they will allow us to use these kind of platforms that are moving and that are jumping up or jointing up again. And this is something that you can see in quite some games, and I just wanted to show you this concept in our particular game that we're building here, so you could make your game a lot more difficult using these kind of spring joints, but at the same time more fun. So let's look at how we can create something like that. Therefore, let's go back to our project and let's go to the scenes and duplicate the movement scene once again. And now I'm going to call this one platform scene, like so. Let's go over to the platform scene. Let's get rid of our cube here once again. Let's make sure that our player is also going to be the prefabs player, like so. And now let's change the world a little bit. So I'd say let's change the position of the player like so, and maybe also the camera a little bit. So let me change the position of the camera so that it's just on top of the player once again, like so. This should be good. All right. So what we can now do is we can, for example, duplicate the playground and move this second playground all the way over there, like so. And let's say something like 40 for the Z coordinate in my case. And now what I'm going to do is I'm going to get rid of this wall as well as that wall here. And let's make this wall a lot wider. So let's scale it up here. We can zoom in so that it goes all the way over there. It can overlap, it's fine. Z of 40 should probably be good for the scale. And then the same goes for this one, Z of 40, but then also repositioning it so that it is closing in on here. All right, so that's fine for now. So this will be roughly our world. And in here, I would like to have some platforms. All right, so what we can do for that is simply create a new empty game object. And I'm going to call this one spring platform. Now, inside of the spring platform, I'm going to add a cube. So let's right click and create a 3D object, a cube, and that one will be called platform, like so. And I think platform is written with one T. That will be a little better. All right, so now we have this platform. Let's change the platform dimensions a little bit. So here the scale should be 6 and 6 for the X and Z coordinate. Let's give it a different kind of color, third-party materials that we had. So here inside of materials prototype, let's use this purple color. So now this will be our platform. Let's reposition it a little bit like so. Let's see how that's going to look like. I think that's fine-ish. So you can really just play around with it. And then the most important part will of course be the spring joints. Okay, so what we can do is we can just go ahead and add that spring joint to our platform. So let's add it here and search for spring joint, like so. Now the spring joint will have a bunch of values assigned to it. Now the spring joint will have a bunch of properties, but I'd say let's look at what spring joints can do for us in the presentation first. All right, so let's look at physical joints. A joint is a component that connects a rigid body to another rigid body or a fixed point in space. Joints can be used to create a variety of interesting game mechanics that are physics-based, like Spider-Man here, for example. So in this example, Spider-Man's rigid body gets connected to a fixed point in space, like a building, while swinging. And the helicopter in front of him has a box that is connected to it. So the helicopter is using a joint as well. So let's go ahead and look at how we can implement it in our game. So back in Unity, we have our platform now, and our platform is using a spring joint. And it has a certain spring strength, and it has a certain anchor as well. So the anchor is just saying where should the anchor be in comparison to the object. So here you can see this is this spot here. So if that's going to be the anchor, then the spring joint is going to try to get back to this point here, to this anchor position. So let's set it to 5, for example. So it will be this little box that you can see here. So now let's see how this is going to look like once we start the game. And you can see that the spring joint is moving up and down because it's hanging on this spring joint. So if we jump on top of it, you see it falls down further because we have a certain mass and it also has a certain mass. And you can also see we can even move it away a little bit and then, wow, it's going crazy. So while this is fine and maybe you want to have this behavior, we can avoid all of this extreme wobbly behavior, and we can do that in the constraints. So let's freeze the X and Z position because we only want the spring platform to move up and down. You can of course also freeze the rotations if you don't want it to rotate towards any direction, but let's try it out with freezing the position now again. And you can see now the joint is going up and down, and once we jump on top of it, it will only go up and down. And of course it will still rotate, but that's what this joint does. It's trying to constantly recreate its position. So you can see we can really impact how much it wobbles based on the anchor. But then there is another setting that we can change, and that is the spring. So if we set the spring to, let's say 500, then the movement will be a lot stiffer. So you can see now it's barely impacted by this effect. Well, at least it's not wobbling by itself. It needs an external force to start wobbling. So it has to do with this spring. So if you change it to something like, let's say 30, you will see that now it springs a lot more. Another aspect that is important when it comes to springs, let me pause it real quick, is the mass of the platform itself as well. So if we change the mass here to 50, for example, and we resume the game, you can see now it's getting pulled a lot further down, but it's also getting pushed back up. So now we are back up and it's pulling it back down again. So it has to do with its mass here. So if I set the mass back to 1, you can see now it's pushing my player away. And let's look at the scene actually. So now, because the mass is so low and the anchor is here at this 5, it's so easy to push it back up. So it's on top of the anchor point here even. So if we move around the anchor, you can see it repositions the entire item. Well, now it's hanging down there. So we can change the Y coordinate, and as you see, the Y coordinate is relative to the position of the platform itself. So now because it's rotating, it looks very different. So let's go back to the default value. You see here there's this connected anchor. So there are two different anchors, the default anchor and the connected anchor. And you can auto configure the connection using this box here, or you can connect your own anchor or change the anchor yourself, the connected anchor. So the X, Y, and Z coordinates of the anchor, you could define those manually yourself, but using the auto functionality is good for what we want to achieve here. Okay, so let's change the spring by default to, let's say, something like 50, and the mass of 1, maybe let's use 2. So this is really something you can play around with to find which value you like most. So it really also depends on the mass of your player. So if the player has a super insane mass, it will push the platform a lot further down. You can, however, use the momentum of the joint to jump higher or less high. So yeah, basically that's pretty much how you can use these joints. So I would recommend that you create a prefab from your spring platform and that you just go ahead and add a bunch more here, or in this case just 2 more. Adding more would not make sense probably. And then just test your game, play around with the values, change the mass, change the anchor point, change the spring force here, and just play around with the values here to see what creates the best effect for your game. So let's run the game once again. Now we have 2 platforms. So I'm jumping on the first one. Actually, I'm not. So I'm directly jumping on the second one. So maybe the challenge would be to jump from one platform to the other by touching one of them or getting to the other side. And then you of course have to play around with the values and tweak them a little bit. Now, of course, as I stated earlier, you could freeze the rotation for your springboards or spring platforms as well. So here, freeze rotation, then they won't be as wobbly. So they won't be rotating, they will always just be stiff. So maybe that is what you want. Okay, so really find out what you like most and create a nice little level where you have to jump between platforms, because here it's easy. We just have 2 platforms and it's difficult enough for me to demonstrate that while playing the game. And for you, you should maybe build something where you have 50 platforms that you have to jump over to get to the other side. And that could be the challenge. So please go ahead and pause the video and try to, or after the video, try to build a very cool level with the spring platforms you have. What you can do is you can even create different kind of platforms, giving them different materials so that they look differently. And then the different colors have different values. So the mask will change, and for example, it will push the player a lot more, or it will just create a very different dynamic for the game. And you could even create 5 different types of platforms. Just give them different colors so that it's easier to understand which is which. All right, so that's it for this video. See you in the next one.